Hi everyone. Today we'll be looking into a very interesting topic of how to handle data skewness in PySpark using a very unique technique which is known as salting technique. So without any further delay, let's get into it. So first of all, we'll import all the important packages and the functions that is required for this ask. Then we'll be starting a Spark session over here, and we'll be creating two data frames. One is df1 and one is df2. The df1 consists of two columns. One is country and value, and the country is basically USA, and the value is 1, which has been repeated 1,000 times. And similarly, we have UK and the value 2, which has been repeated 100 times. And we have India and the value 3, which has been repeated 50 times. So you can see over here, like the data is very skewed. Let's look into a preview of this particular data, which we can see over here. So first of all, like the overall preview looks like this. We have some country names and the values corresponding to it. Here we can see the preview of USA, but UK and India is also present lower down the list. Then like if you look into the data, you can see like the data is pretty much skewed towards USA. The counts, the number of records for USA is much more as compared to India and UK combined. So this kind of situation is known as skewness in data, where the whole of the data is skewed to a single value or a group of values. Similarly, we are creating another data frame which is having two columns, the country and the value. Here we have only three records. One is like USA and the value corresponding to is A, UK and the value corresponding to it is B, and India and the value corresponding to it is C. So when we generally do a join of df1 with df2, then like in this particular scenario, there is a bottleneck that happens when we do a join of df1 and df2. Generally it takes much more time than it is expected because of the skewness in the data. So we will look into that in the next part of the code. So to see, like suppose we have the data and we have decided to divide it into four partition, and each partition will be handled independently. So to see how that particular repartitioning occurs and what are the values that is present in each of the partition, first of all we partition the data in four different lists. Then we are using this gloom function. The gloom function converts each partitions of your distributed datasets into an array of elements, effectively giving a view of how your data is physically distributed across the cluster. So if you see, like here we have uh, collected the partitioned data into partition contents using this gloom function. And when we are looping over this partition contents using this particular piece of code, then we can see partition 0 has 100 records, partition 1 has 50 records, partition 2 has 1000 records, and partition 3 has 0 records. So four partition where a particular partition is handling most of the records while the rest of the partition are handling few records. This leads to inefficient resource utilization. So let's understand this in more detail. Partition is actually logical division of data that can be processed independently. Now consider this particular case where like partition 0 has 100 records, partition 1 has 50 rows, partition 2 has 1000 rows, and partition 3 has 0 rows. So what happens in this particular case is like it will take more time to process this particular partition 2. Why? Because it has like uneven distribution, and partition 2 has like more records, like 1000 records as compared to other partitions. And why partition 2 has 1000 records? Because the data is skewed. While worker nodes processing this partition 2 will be busy, others might sit idle. This leads to inefficient utilization. So instead of this uneven partition, say like we have 2000 records and it is distributed evenly. In partition 1 we have like 500 records, in partition 2 we have 500 records, partition 3 500 records, and partition 4 is having 500 records. So since this is like evenly distributed, all the worker nodes can complete this task, any operation on this particular records evenly and on time. If it is not evenly distributed, then few, as we can see over here, few of the worker nodes will finish their work quickly because there is like less record or no record, and there would be one partition where like the worker nodes will take more time to complete this. It leads to inefficient utilization. So from that point of view, we should at least partition the data in such a way that if not evenly distributed, it shouldn't be skewed. At least it should be like have a good distribution across all the partition. So we will look into this solution in the next step.
That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data-driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.